ENCLAPSലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hi. We know that according to Ohm's law, the current flowing through a conductor is directly proportional to the potential difference and inversely proportional to the resistance. When the current flows through a conductor, it resists the flow. It is called as the resistance of that conductor. Each conductor is having different resistance and is denoted by the letter R. The unit of resistance is ohm. Now, let us see what are the factors influencing resistance. The length of the conductor. As the length of the conductor increases, the resistance of the current to flow along the length also increases. That is, as the length increases, so does the resistance. Therefore, the resistance is directly proportional to the length of the conductor. Next one is the area. Current flows through a conductor just like water flowing through a pipe. If the thickness of the pipe is less, the amount of water flowing through the pipe would also be less. If the thickness of the pipe is increased, the amount of water would also increase. Similarly, when the thickness or the diameter of a conductor decreases, the amount of current flowing through it also decreases. And it's the same case with respect to increase in diameter or thickness. If it increases, the amount of current increases. What about the resistance? The resistance would decrease if there is an increase in diameter or thickness of the conductor. So, it is understood that the resistance is inversely proportional to the area. Next is the characterization of a conductor. Different conductor is having different resistance. For example, the resistance of copper wire is not that the resistance of an iron. Temperature. As the temperature increases, the resistance of the conductor also increases. According to Ohm's law, here we have three equations that connects the potential difference, current and resistance. A very easy method to remember this formula is the Ohm's triangle. If V is to be found out, the remaining is I and R. Look at the line between them. It comes out to be V is equal to I into R. If we need to find I, just look at the line between them. It looks like V by R, isn't it? So, the equation is I is equal to V divided by R. Now, finally, in order to find the resistance R, either you hide the letter R or find the line between V and I. The equation comes out to be R is equal to V by I. We have learned an equation to find out heat, isn't it? H is equal to VIT. Now, let us look at the effective resistance for converting electric energy into heat energy. According to Ohm's law, we know that V is equal to IR, and from the heat equation, H is equal to VIT. Substituting the value of V from Ohm's law into H, we get H is equal to IR into IT. I and I together becomes I square. Therefore, H is equal to I square RT. This is the second equation of heat. This equation can be used to find the heat generated in the circuit when I current flows through a resistance R. It was James Prescott Joule who made this law, and this law is called as Joule's law. The heat generated in a current carrying conductor is directly proportional to the product of the square of the current, the resistance of the conductor and the time of flow of current. That is, H is directly proportional to I square RT. In order to change the proportional sign, either multiply it with a fixed number or replace it with a constant. Since the constant used here is 1, heat H is equal to I square RT joules. This is the Joule equation, where I denotes the intensity of electric current in amperes, R denotes the resistance in ohm and T denotes the time in seconds. Now, let us complete a list based on Joule's law. Here, the amount of heat generated in each cases with respect to the change in current, resistance, time can be found using Joule's equation. The resistance of a conductor is 2R, the intensity of current is I, and the time taken for the current through the flow through the conductor is T. Then H is equal to I square RT is a Joule's equation. Substituting the value of R into this very same equation, H is equal to I square into 2R into T, that is equal to 2 into I square RT equals 2H, that is the heat has increased, it's twice the value. The resistance is R, the current flowing through the conductor is 2I and the time taken is T. Then H is equal to 2I the whole square into R into T, that is equal to 4I square RT equals 4H. That means the heat has increased 4 times. R by 2 is the resistance, I is the current flowing through the conductor and T is the time taken. Then H is equal to I square into R divided by 2 into T equals I square RT divided by 2 equal to H by 2. The heat has decreased to half the value. When the resistance is R and current is half the value, and that is I by 2 and time is T. Heat is equal to I by 2 the whole square into R into T equals I square RT divided by 4 equal to H by 4. The heat has decreased to a quarter value. The resistance of the conductor is R, I is intensity of current flowing and time is 2T. H is equal to I square R into 2T equals 2I square RT equal to 2H. Heat has again increased, it's twice the value. The resistance of the conductor is R, I is intensity of current and time is equal to T by 2. That is, we have reduced the time to half the value. Therefore, H is equal to I square into R into T divided by 2, which is equal to I square RT the whole divided by 2 equals H divided by 2. The heat has reduced to half its value. Therefore, the heat generated is depending on the current flowing through the conductor. From the above data, it is clear that current is the most influencing factor in generating heat. As the current increases, the heat also increases proportional to the square of the current, and as the current decreases, heat also decreases proportional to the square of the current. Now, we have two equations of heat. H is equal to VIT and H is equal to I square RT. If the equation H is equal to I square RT is equated to the Ohm's law equation I is equal to V by R, H is equal to V by R the whole square into R into T, that is equal to V square into R into T divided by R square. If each R value is cancelled from the numerator and denominator, we get the exact equation of heat as H is equal to V square T divided by R. Now, let us move on to our questions. What would be the heat developed if a current of 0.2 ampere flows through a conductor of resistance 200 ohm for 5 minutes? The given data are resistance R is equal to 200 ohm, current I is equal to 0.2 ampere and time is equal to 5 minutes. Always make sure that the units are in the standard form. Here the time is given in minutes, so we have to convert it into seconds. Therefore, time is equal to 5 into 60. 1 minute is equal to 60 seconds. The value comes out to be T is equal to 300 seconds. Substituting the value in the Joule's equation, H is equal to I square RT equals 0.2 the whole square into 200 into 300 equal to 0.04 into 200 into 300 equals 2400 joule. If 1 calorie is 4.2 joule, then 1 joule is equal to 1 divided by 4.2 calories. Therefore, 2400 joule is equal to 2400 into 1 divided by 4.2, which equals 571.43 calories. Let's move on to the next question. What would be the heat generated if a bulb of 230 volt and a resistance of 920 ohm works for 3 minutes? The given data are voltage V is equal to 230 volt, resistance R is equal to 920 ohm and time T is equal to 3 minutes. 1 minute we know it is equal to 60 seconds. So, convert the minute to seconds, which equals 3 into 60 equal to 180 seconds. As we know that the value of V and R are only given, we have to use the Joule's equation. H is equal to V square T divided by R, which equals 230 the whole square into 180 divided by 920. That is equal to 95,22,000 divided by 920 equals 10,350 joules. Let's move on to the next question again. Calculate the heat developed when a current of 3 ampere flows for half an hour through an electric iron box designed to work under 230 volt. The given data here are V is equal to 230 volt, current I is equal to 3 ampere and time T is equal to 30 minutes, that is equal to 1800 seconds. Here we know the value of V, I and T. So, the formula of heat which we have to use is H is equal to VIT, that is equal to 230 into 3 into 1800 equal to 12,42,000 joule. Question: details of 2 electric heaters are given below. How much will be the heat developed if they are made to work for 5 minutes each? And also find the current consumed in each heater. Heater A, working voltage is 230 volt, resistance is 1150 ohm, working time is 5 minutes. In case of heater B, working voltage is 230 volt, resistance is 460 ohm, working time is 5 minutes. Let's solve the heater A first. Convert the 5 minutes to seconds, that is equal to 300 seconds. By using the formula H is equal to V square T divided by R and substituting the value, we get H equals 230 the whole square into 300 divided by 1150 equals 13,800 joule, and the current I is equal to V by R equals 230 divided by 1150 equals 0.2 amperes. Now let's solve the heater B. Make sure that all the units are in standards. Again, the 5 minutes should be converted to seconds, which comes out to be time is equal to 300 seconds. Using the formula H is equal to V square T divided by R and substituting the value, it comes out as H is equal to 230 the whole square into 300 divided by 460 equals 34,500 joule, and the current I is equal to V by R equals 230 divided by 460, and the answer is 0.5 ampere. So, we have learned what is Joule's law and the main three formulas in order to find out heat. While solving a problem, always make sure that select the apt equation with respect to the values given.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.